Hello everyone. Jo Hello everyone. Let's start our next lecture module on electrochemistry. Let me start this module in with the balancing redox reactions. I hope you all have reviewed your content related to this electrochemistry from the Gen Chem 1. Under Gen Chem 1, you learn the definitions for the oxidation and the reduction. So the oxidation was explained as the oxidation number increase. This increment of the oxidation number was uh, done or happened due to releasing the electrons. Reduction is the process where the oxidation number was decreased by accepting electrons. So when we are balancing a chemical reaction, the first thing that we should understand or we should identify the two half reaction. One half reaction is the oxidation and the other half reaction is the reduction. So the redox reaction is a combination of this oxidation and the reduction. So in example, look at this, the oxidation reaction. Example, Fe2 plus goes to Fe3 plus. So in Fe2 plus, the oxidation number is 2 plus and the product is the 3 plus. In this case, oxidation number has been increased. Therefore, it is the oxidation. The other reaction should be the reduction. In that case, the chromium in dichromate ions, the chromium is in the +6 oxidation state, and in the product it was reduced to +3. So that's the reduction. So the next step, we'll then balance the half reaction regarding the atoms other than oxygen and hydrogen. So we are balancing the other elements, right? In this case, so in the oxidation reaction, we don't need to worry about that because in the reactant side, we have 1 mole of Fe2 plus, and in the product side, we also have 1 mole of Fe3 plus. So we don't need to worry about that. But in the reduction half reaction, in the reaction side, we have 2 chromiums. Therefore, you have to add the coefficient of 2 in front of the product chromium 3 plus. Let's move to the next step. So now we are balancing these two half reactions for the oxygen by adding water molecule to the correct side. So again, with the oxidation reaction, there is no oxygen involved in there. So you don't need to worry about adding the oxygens or water molecules. But in the reduction one, the reactant side, we have 7 oxygens. So in order to balance the oxygens on the product side, we have to add 7 water molecules. Next step. Now, since we add the water molecules, so the next step, we should balance the sides of these half reactions for the hydrogen by adding it as H plus. So again, you don't need to worry about the oxidation half reaction since it is not involved. So no oxygens or hydrogens are involved in that reaction. But in the reduction reaction, in the previous step, we added 7 water molecules to the product side. Therefore, we should add 14. So here we have now added 14 hydrogens. Therefore, those hydrogens should be balanced by adding as 14 H pluses to the reactant side of that half reaction. Right. Now we have both half reactions which were balanced by their atoms, and they were balanced by their hydrogens and oxygens. Now we're going to balance their charge by adding electrons. So in oxidation, by the definition, it should release the electrons. Therefore, electrons should be added to the product side. So Fe2 plus goes to the Fe3 plus. The oxidation number was increased by factor of 1. So by the unit, by 1 unit, therefore 1 electron should be added to the product side. In the reduction, by its definition, it should gain electrons. The difference between this, the chromium, here we have +6, here we have +3 definition, charge. Okay, so you can just multiply it by 2 and 3 multiplied by 2, since there are two of those. So the difference is like 12 and 6. The change is 6. So you have to add 6 electrons to the reactant side, because these 6 electrons will be gained during the reduction for to the uh, by the reduction of the dichromate ions to result chromium 3 plus ions. Next, you will multiply one or both half reactions by particular numbers to make the number of electrons equal for these both half reactions, right? So the reduction reaction, now we have 6 electrons on the reactant side there, but the oxidation one had only the change of 1 electron. Therefore, the oxidation half reaction should be multiplied by 6 to make the electrons equal to 6, right? Next, we add the both half reactions together to cancel the electrons out. Here is that the net reaction. This is the balanced chemical redox reaction for this oxidizing iron 2 plus to iron 3 plus by dichromate ions under the acidic conditions. Right. That's why we see the H pluses as in the reactant medium. But if this reaction was done under basic conditions, then we should add the hydroxide ions to each side of the equation. So, and then we have to add the additional water molecules to make this reaction balance for the hydrogens and oxygens. Right. The next one, this is for your turn, for your practice. Here I'm going to talk about the redox reaction between the permanganate ions and the iodide under basic conditions to produce manganese 4 oxide and molecule iodide. So if I put the sentence, the wording into the um, chemical formulas, this would be the reaction, right? So first of all, we should find what is oxidizing and what is reducing, right? So manganese, in permanganate ions, the manganese is in +7 oxidation state. In manganese dioxide, manganese is in +4 oxidation number. Therefore, the manganese is reducing from +7 to +4, right? Yeah, again, in iodide ions, the iodide is in -1, and when it goes to iodine, it would be 0, so it is oxidizing, right? By increasing the oxidation number. Right, so here I separate the two unbalanced reactions into the oxidation, as in oxidation half reaction and the reduction half reaction. Next, I'm going to balance for the mass, excluding the oxygen and hydrogen. So I added the 2 in front of the iodide ions in order to balance the iodine. Next, I'm going to balance the reaction for oxygen by adding the two water molecules into the product side of the reduction half reaction. Because here in the reactant side, I have four oxygens, and the product one, manganese 4 dioxide, oxide has only two oxygens. So the additional two oxygens were added as two water molecules. Next, I'm going to balance it for the hydrogens by adding H pluses. So now altogether I have four H plus hydrogens here. Therefore, two H pluses added to the other side of this reaction. Next, I'm going to balance the total charge by the both half reactions by adding electrons. So the first one in the difference is 2 when it goes from iodide to I2, because here minus 1 should be multiplied by 2. So the answer is -2. So now it's going from -2 to 0. So the change is 2 electrons. The reduction half reaction has the difference of the 3, so that 3 electrons were added to the reactant side. Next, I should balance the charge by multiplying the equations by certain numbers. So I cannot I cannot make it equal. So I have to multiply the oxidation half reaction by 3 and the reduction half reaction by 2. So then I get the two half reactions like this. Then I add those two together and I get to 8H plus 2MnO4 plus 6 iodide goes to 2MnO2, 3I2 and 4H2O. The next step. Now, this reaction is done under basic conditions. Therefore, I should add the equal number of hydroxides ions to the H pluses to the both sides. So in the reactant side, I have 8 H pluses. So I added the 8 hydroxides, as well as you have to add the 8 hydroxides to the product sides as well. So next, the 8 H pluses and 8 hydroxides ions equals to 8 H2Os. So the product side has 4 H2O pluses and 8 hydroxides ions. Right. So the final calculation, the final equation will be 4H2O. So then cancel out the 8H2O to 4H2O. So the reactant side will have 4H2Os and 2MnO4, 2 permanganate ions, 6 iodide ions goes to 2MnO2, 3 iodine and 8 hydroxide ions.